our vehicles when they're re-entering Earth atmosphere, so we keep our astronauts safe. So this summer I traveled to Brussels, Belgium, and did some work there on the plasmatron. It's a unique facility in the world, and it creates this pure plasma that can actually simulate the re-entry of space vehicle into the Earth's atmosphere. And this is the Georgia Tech Aerospace logo, in case you were wondering. And our motto is progress and service. And the progress in our society is these small space transport vehicles. And this is a re-entry vehicle, the ESA Expert vehicle, and the European Space Agency. Sorry, I'm still in Europe terms. And basically, what we're trying to do is we have these nice numerical simulations, but we don't have the experimental grounds to verify these. And so that's where the plasmatron comes in. That's where these techniques are coming in. Obviously, flight testing is too expensive. So when we're doing these studies, we're looking for heat flux and we're looking for catalyticity. A non-catalytic surface, disassociated atoms bounce off and remain separated. Fully catalytic, they bounce off and come together, producing a large amount of heat. This heat gets transferred to the thermal protection system and is dangerous to the life safety of the vehicle. So what allows us to carry on these experiments and make them relevant is local heat transfer simulation. And it's a theory that says that the stagnation point of any re-entry body, we can relate that to the stagnation point in our test cell. And that allows us to draw comparisons from this vehicle to our ground test facility. Here's the plasmatron. To give you a scale, this is a normal computer model. It's a 1,200 kilowatt machine, sub-atmospheric. And what it does is it produces a pure plasma to the right by taking an electric coil inside of the quartz tube. We run gas through this coil,